Hi, today we're going to look at combining transformations. So we're not just going to be looking at a single transformation. We're not just going to be looking at describing a single transformation even. We're going to be looking at, maybe performing two transformations and then seeing what we could have done using a single transformation to get to the same place. And I just want, this is just building on what we've already covered. So basically it's kind of almost practice and I want you to try and figure it out as you go along. So I'm going to show you the questions and then I'm just going to go through the answers as we go along. Good luck, do your best with this. You got this, and consolidate and improve your knowledge of transformations. Right, first question. Hopefully you pause the video and you've had a go at it. This is what you should have got. So if you reflect triangle A in the x-axis, it goes over here. Then in the y-axis, it goes to here. Describe the single transformation that maps triangle A onto C. That means like what you do to A to get to C. And these are the two possible answers. It's either rotation of 180 degrees about the origin, 0, 0, or you could have gone with this enlargement by scale factor -1. Okay, they are equivalent. Next question. This one here. All right, so if we're reflecting in x equals 1 and then in y equals 2, actually what we end up is with a rotation going on again. But like I say, this time it's a rotation from 1 and 2. So rotation 180 degrees about -1 and 2. You could again have gone with an enlargement by scale factor -1 about that point. So you can see a little pattern going on here. When you reflect in the x and then in the y, it's equivalent to a rotation. That's happened in both cases. You might be interested in thinking about whether it will be always true. Right, this next question, we're reflecting in x equals -2 and then not in y equals a constant, but in y equals x. What's going to happen? Give it a go. Right, this is what should have happened. You would have got to B, and then you would have got to C. And what does that actually give to you? It gives you a rotation, but this time it's 90 degrees, clockwise about -2, -2. We can't use the enlargement idea now. Okay, that's the answer. Okay, if you try this one, then 180 degrees about the origin takes you up to here, and then in the x-axis takes you to here. Describe the single transformation is actually just a reflection in x equals 0. Moving on, how about this one here? Rotation followed by a translation. Well, this is what I get. So the rotation takes you to B, and from B we get to C, and then you have to, this is a bit trickier now because it's going to be a rotation actually, but where's the center of enlargement? Well, again, like think about what I said. The center of enlargement is going to be the same distance away from corresponding points. So that one there and that one there are corresponding points. So just like maybe try around this region here. Actually, it's not quite that because they're not. Although this is the same distance away from these corresponding points, it's not away from all of them. It's actually here. Ends up being a rotation by 90 degrees clockwise about -2, 2. Okay, what about some enlargements? If you enlarge by a scale factor 2, then about scale factor 0.5, what happens? You should get this going on, so be really careful here. You've got your center of enlargement, you've got your ray lines, it's a bit fiddly. You'll end up with with it being at C, and then if you compare that with A, it's simply a translation by -1, -4. Nice one. Just a little intermediate bit, which single transformation is the same as reflecting in two parallel lines. What would you do for this? Reflecting in two perpendicular lines and two translations. The answers are, for the first one, it's going to be a translation. If you reflect in parallel lines, like you're going to jump to the, maybe to the left and back to the right, you're going to end up in the same orientation actually, and so it's just going to be a translation. Whereas reflecting two perpendicular lines, we've actually already seen this. It's going to be a rotation. We saw this in the first question. Okay, that will always, I haven't quite proven it, but that will always happen. And then two translations is equivalent to another translation. You can actually just add the vectors together. Moving on. So now we've got reflections in two diagonal lines. This is what happens. Ooh, interesting. Jumps to here. And actually, that is a rotation by 180 degrees about 0, 0. Will that always happen? I think it probably will. Carl reflects triangle A in the x-axis and then in y equals x. Amy reflects A in line y equals x and then in the x-axis. Should they be in the same position? Well, this is what happens. It actually doesn't quite pan out like that. So if you reflect it in the x-axis and then in y equals x, it ends up over here as E. But if you do it in y equals x first, it ends up here and there. So the order matters. That's what I'm trying to get across in this question. No, C and D are in different places. So make sure you're showing your, label your triangles really carefully so they can be understood. Don't be afraid to get your lines in to help you. Shape A can be transformed to shape B by a reflection in the x-axis followed by a translation CD. Find the value of C and the value of D. So the first thing really to do is actually get that reflection in. Okay, reflect it there, and then you just need to, it's just a describing translation question. So there's just this extra little step that you have to do. Triangles A and B are drawn on the coordinate grid. Describe fully the single transformation that maps A onto triangle B. Similar to, this is just a describing transformations question. It's the reflection y equals x. You have to recognize it's not a rotation, and that's basically going to mean it's got to be one of these reflections and it's in this diagonal line. However, we can also map onto triangle B using a combination of two transformations. We could do a transformation T followed by a reflection on the line x equals 0. Describe fully transformation T. I like this question because it gets you thinking a bit more, because this time we can't actually do the transformation T to A. Like, we don't know what it is, but we know that we're doing some sort of transformation and then we're reflecting in x equals 0. So what we have to do actually is reflect B back into x equals 0 and see where it would have ended up. See where it would have originated. So, because when you reflect it and you reflect it again, you'll get back to the start. So it must be that after we've done T, we'll get to this red triangle here. And then it's another describing transformations question. Okay, so yeah, do the reflection backwards. Then it becomes a rotation 90 degrees clockwise about 0, 0. All right, hopefully you're feeling happy with that. Well done on your efforts. We've practiced combining transformations. You might want to play around with it a little bit more. Maybe, think about just draw a grid and have a shape, and then think about what's going to happen if can you sort of work out what will always happen if you do a translation and another translation, or if you do a translation and a rotation? What would that be equivalent to? Can you sort of categorize this, develop your understanding? That sounds like a good open question. I'll leave you to it. Go for it.